I'm sharing my screen. I don't know what, I did not write solutions yet, so I don't know what it is about. I looked at it when I chose it, so it's not out of the blue, but maybe I didn't read the question again. I hope not. 16. 16. 16. Oh, this one. Okay, very good. So we have limit 2 minus 3x equals -4 when x approaches 2. I am stopping sharing. Okay. Okay. So the problem is asking us to use the epsilon delta definition, the formal definition of the limit, to show that this is true. Of course, we should always check. This is not a trick question. It's not a tricky question. We're not asked to show something that is not true. So, but I will plug it in. 3 times 2 is negative, well, okay, -6. 2 minus 6 is -4, so that's correct. So I have to write the equivalency symbol because I will have to show 2 ways. And then I start with, for every epsilon positive, I will find, or there exists a delta positive such that every time I pick x close enough to, and you'll tell me what, this will always imply that the function value will be close enough to what? Anyone would like to help here?
Is it close enough to the
Which one are you giving me? Let's start here.
The bottom. I was working on the bottom one.
Fine.
Yeah. Function 2 minus 3x plus 4.
Excellent. And thank you, Mark.
X minus 2.
Very good. Do we all agree with this? Thank you, Kush. Do we all agree with this so far?
Yes.
Okay, we have to start from the end. So part 1, we start here. Can anyone dictate our next step?
The absolute value of 6 minus 3x is less than...
Right. Perfect. But I always want descending order. But you're correct. It's 6 minus 3x, no question. No question. But I'm lazy in writing sometimes, and you know that. And I like to put it in descending order from the beginning so I don't have to write it again. You don't have to, of course. Good. Our next...
Wouldn't you still be able to do it with a negative x?
Of course.
All right. That's what I did, and it didn't really affect the problem at all.
Well, we'll see in a moment. So this is our starting point. Can anyone tell us the target?
Yes. Can we have like 3 outside?
Can you tell us? No, not yet. Kush, hold on one second. Can you tell us what is the target?
X minus 2.
Exactly. This is our target. If you are aware of that, the whole thing will take less than a minute. Thank you, Gia. Good. Yes, Kush, if you'd like to continue, I'm ready now.
We can have a -3 outside and then...
Very good. -3. And what else?
X minus 2.
Very good. What do we do next? And remember a few minutes ago, I said the next step is very clear what it has to be.
We can have a -3 absolute value.
Very good.
And another absolute value is going to be...
Excellent. Perfect. Next step.
We can have a -3, then absolute value x minus 6. It's going to be 3 because...
very good. And then?
Then the final answer is going to be delta...
I'm not finished yet.
Okay. It's going to be x minus, absolute value x minus 2, less than epsilon over 3.
That's it. So what do we conclude now?
We can have a delta equal to epsilon over 3.
Excellent. Well done. So 2 reverse. The steps, of course, you know what I mean, to show that delta equals epsilon over 3 works. Great job. Well done. Anything else? Anyone? Do we have other questions?
So, will we still be able to just use 2 minus x is less than epsilon over 3 since it's the same thing, and then just replace that with delta? Or do you want us to write x minus 2?
So let me write on the side what you said so I can address that, because I'm not sure. Can you say it again?
So I did the same process, I just didn't rewrite the equation. So my final value was absolute value of 2 minus x is less than epsilon over 3. Would that still be acceptable? Okay.
To be honest, they mean the same thing. So indeed, x minus 2 in absolute value is indeed the absolute value of 2 minus x. But we cannot accept it. But you are correct. Honestly, okay. 2 minus x in absolute value is the same with x minus 2 in absolute value. How come? Because when I factor out -1 here and I put in absolute value, it'll still turn into this. But we cannot use this. We have to specifically, it's a very good question, we have to specifically have the absolute value of x minus 2. This is our target.
I think I did the same mistake too.
Therefore, we have to pull out -3. That's what I'm asking from the very beginning. Where is my starting point and what is my target? So I know everything else has to fall into place. This is what I'm after and nothing else. Anything else will not be accepted. Very good question. Okay? However, I have to be honest and tell you that these two mean the same. But we cannot accept that in this situation. But theoretically, they are the same. Good. Anything else? Do we have anything else? Anyone? Okay, then I'm back to what I promised. I promised a problem here. Let me find it again. I should be able to find it. Oh, but it's not the section that I'm talking about then. This is the section I'm talking about. Okay, and this is the problem 48, and you will have to do 47. I know 47 has the answer. I don't care. Similar problems will be on the test and the final. So this is a very important type of problem. So please write it down. Okay, so we're looking at 48, and this is in section 2.5. Okay, let's copy it, all of us. So it's x squared minus 4 over x minus 2 for less than 2. Ax squared minus bx plus 3 for, and then 2x minus a plus b for x greater than or equal to 3. Okay. Some time ago I found an error here somewhere, but I don't remember now what it was, so that's okay. Okay, ready? Oh, sorry. So the question was asking us, find the values of a and b in such a way that this function is continuous on all real numbers. So find a and b. So it's continuous. So a comma b question mark such that f of x is continuous on negative infinity to infinity. That's what we mean when we say continuous everywhere. Okay. Again, there are certain steps that we have to put in writing. So first of all, I'm looking at this, and I'm going to ask you what type of function is, I know I skipped the first step in a moment. What type of function is this?
Quadratic.
Perfect. What type of or polynomial? Perfect. What type of function is this?
Linear.
Perfect. Or polynomial, same thing. So where are these continuous?
Those are continuous on all real numbers.
Excellent, because they are defined everywhere. Perfect. Now let's come back to the first one. What is our first thought always when we look at any problem, equation, function, blah, blah, blah? What is our first thought?
There is anything we can simplify?
Excellent. Great. Great. So then we have x squared minus 4 divided by x minus 2. Obviously, x cannot be...
Can't be 2.
Very good, but there is no problem there. I don't have to do anything extra because x is less than 2, so that's okay. It's clear. So then what would you think of doing?
We would factor the numerator.
Great job.
It's going to be x plus 2 times x minus 2.
Good. What do I do next?
Knock off the x minus 2 on the top and bottom.
I have to state a restriction, but there is no need. Remember, I cannot simplify before I state the restriction, but it wasn't necessary because where this piece is defined, it doesn't have to anyway. But I cannot simplify before I state the restriction. So then the answer is x plus 2, which is much nicer. That word that I didn't even remember what it was for a moment. Okay, so because I didn't put the word in front of it. So it's x plus 2 when x is less than 2. It's ax squared minus bx plus 3 for x between 2 and 3. 2 but not 3. And 2x minus a plus b for x greater than or equal to 3. So please remember, this is the key to look at the function. Don't rush and simplify it fully. There is nothing I can do here, nothing I can do here, but of course I had something to do in the first branch. Always simplify, factor, always. Okay, perfect. So now I want to find the unknowns. I don't have a, b, and by finding a and b, I would like to make sure that this function is continuous everywhere. And again, the following steps are mandatory. Please write them down with me. Step number 1, I have to identify, which you already did for me, 10 did. So x plus 2, ax squared minus bx plus 3. I said 3. I was looking already at next step. 2x minus a plus b are polynomial functions, comma, hence, defined everywhere, and not defined. Continuous. Of course defined, but I needed continuous everywhere. You don't have to erase it. Just say defined and continuous everywhere. That's good. But I didn't mean that. We already knew because they were polynomials. We were talking about continuity here. Okay, next step. Our next step is continuity where? Where could this function have a problem? So this is continuous everywhere, continuous everywhere. Specifically, if they are continuous everywhere, this is continuous to the left of 2. This is continuous between 2 and 3. This is continuous to the right of 3. That's very clear. If they are continuous everywhere, they are continuous on their individual pieces. But where could this function have an issue? Ian, where do you think this function could have a problem?
I'm not really sure.
Carson?
In case there's a value in one of the second 2 equations where x is undefined.
The function is defined everywhere.
Would there be an issue potentially 3.
Say it again.
Would there potentially be an issue at 3?
Only?
Only if
I'm saying only at 3.
It would be the vertical asymptotes, right?
Okay, so let me write this. No vertical asymptotes for polynomials. Ever. See, that's why it's so important to have communication. So then we clarify these things, because maybe you wouldn't ask this question if I didn't ask it. So this is very important to tell me what you think. That's very important to me. We never talk about vertical or horizontal asymptotes for polynomial functions. Okay, so coming back. Do I have, hold on, just hold your thought for a second. Let me look back, because I kept the homework but I didn't keep the, I kept all the homeworks, but I didn't keep the, yes, here it is. I didn't keep the lecture notes. I mean, I can go back in time and share my screen. Okay, so this was a piecewise defined function. It had 4 pieces, x3, 2 minus x squared, x minus 3. We decided that this function was defined everywhere. Where could this function have a problem, and why?
The function could have a problem where the piecewise pieces of them come together.
Absolutely. Absolutely. At 1, look what happens. There is no problem here, but there is a potential problem at 1. And of course, there is a potential problem at 2, a big one. So that's why this function is not continuous at 1, because these 3 pieces are not the same. And it's not continuous at 2, because these 2 pieces are not the same. Do you understand what I'm saying when I talk about a piecewise defined function? Who answered a second ago, please?
Derek.
Thank you, Derek. Okay, so if this is continuous everywhere, that's fine. If this is continuous everywhere, that's fine. But the problem that this function could have is exactly where the pieces come together. I could have not said it better. So at 1 and at 2. Okay, so now let me put this away. So now, coming back, where could this function encounter problems?
Counter problems at 2 and 3.
That's it. So now number 2, continuity at 2, of course, better. Let me write correctly, at x equals 2, and continuity at x equals 3. Who would like to state the definition of continuity at a point?
The limit from the left has to exist. The limit from the left has to equal the limit from the right and equal the value at that point.
Brilliant. Thank you. So the limit as x approaches 2 from the left must equal limit as x approaches 2 from the right must equal f of 2. Okay, Josh, will you tell me what should I put in here for the limit from the left of 2?
For the left of 2?
Yes.
It's x plus 2.
Brilliant. Gabriel, from the right of 2.
On the right is ax squared.
Excellent. Very good. So minus bx and plus 3. And which function will I use to plug in 2? Mickey.
What was the question?
Which function do I use to plug in 2?
You use the ax squared minus
Brilliant.
bx plus 3.
Thank you. So this is in x squared minus bx plus 3. Well done. Okay, now who can give us the limit here? The first limit. Isaac. What is the first limit, please? This limit. Isaac, are you with us?
Hello?
Yes. You're muted, I guess. Okay, so can you give us the limit here?
Would it be -2?
Why?
Or
Lindsay, what will be the limit here?
Would that be 0?
Why?
Oh, I was plugging in. Oh, wait, never mind. It would be 4, sorry.
Good, no
That's
worries. Okay, Trey, what would be the limit here? Trey, are you with us? You're muted. Yes? Will you give us this limit?
Sorry, I'm not sure.
Okay, Ravon?
It'd be A4 minus.
Very good.
B2 plus
4a minus 2b plus 3. Great job. Okay, Leonardo, will you give us the function value at 2?
It would be the same as the
Of
previous
course.
one, 4a minus 2b plus 3.
Excellent.
I have a question, though.
Yes?
Didn't we have an asymptote for the first function, x plus 2?
X does not equal 2. So it would have had, because the factor simplified, it would have been a hole in the graph. But x equals 2 is not in the domain of this piece. X equals 2 is not here. So we cannot even discuss x equals 2 at all.
Okay, thank you.
Better?
Yes.
Perfect. Okay. I think that is possibly Oscar. Let me mute you. Okay, you're muted. Sorry. Okay, so can anyone not look at this because I put it in too soon and I write too big. Sorry about that.